Okay, I'm going to talk about our research semantic type disambiguation for Japanese verbs. This is the abstract of our research. Our purpose is to classify Japanese verbs according to its sense, according to semantic types of Japanese proposed in our previous research with the context. For example, Japanese verb mitas, which means either to fill or to satisfy, has the semantic type action with context a glass with water, and has semantic type modification with context with a condition. We constructed semantic type disambiguator and achieved 70% accuracy. Then what's the semantic types? Semantic types aim to classify Japanese predicate according to its sense. It is as fine-grained as part of speech, such as verbs and adjectives, and signify the word sense more accurately. I'm going to describe further with some background. One of our interests is sentiment analysis. According to Yan and Cardi's study, whether or not a statement includes the speaker's opinion depends strongly on its predicate. So we assume that it's important to classify predicate according to sense. On the other hand, part of speech is generally assumed to signify the word's semantic features. For example, verb signifies observable action or changes, and adjective signifies states or properties. Therefore, part of speech information is often utilized in NLP tasks. Please note that Japanese predicate can be composed of just one adjective. Whether the predicate is composed of a verb or an adjective can be informative. However, there are some exceptions. There are verbs behaving like adjectives. For example, verb to excel signify a property, and verb to satisfy signify a state. Because part of speech is classified based on not only semantic criteria but also morphological and syntactic criteria. On this subject, in our previous research, semantic type is proposed. In contrast with part of speech, the semantic types are classified based on only semantic criteria. The semantic types have 4 types: action, change, emotion, and modification, which signify the predicate's semantic feature. I'm going to introduce its definitions, their definitions. First type, action, is expression that signifies an observable motion, and in which the state does not change before and after the motion. For example, verb to swim, to eat, to walk, and to run have a type action. And second, type change is expression that signify a state as a result of a motion, and in which the state after the motion differs from the state before the motion. For example, the verb to try and to die have a type change. Third type, emotion, is expression that signify an operation of sense organ or mental action. For example, verb to see to feel, and to think have a type emotion. And last type modification is expression that signify the property, a shape, a being, or a relation. For example, the verb to excel, to differ, to be, or and to abound have a type modification. According to our previous research, all adjectives are of type modification, while verbs are of multiple types. I showed comparison between part of speech and semantic types again. Part of speech is classified based on not only semantic criteria, but also morphological and syntactic. Especially in Japanese, classification criteria between verbs and adjectives are only morphological. And one word usually have one part of speech. On the other hand, semantic types is classified based on only semantic criteria. And as I said, verbs are multiple type. In other words, a verb can take different type depend on its context. Then they annotated possible types to all Japanese verbs. For example, the verb to walk, Japanese verb arc, which means to walk, is annotated only the type action. And Japanese verb mitasu, which means either to fill or to satisfy, have the both type action and modification. The annotated data is available at our laboratory's website. We assume that the verbs type can be decided to single type with the context. So we define to decide the verb semantic type as a semantic type disambiguation. We then constructed semantic type disambiguator. The disambiguation is conducted sentence by sentence. Word segmentation and post-tagging are conducted to each sentence. We assume the disambiguation as a classification problem, so we use the support vector machine (SVM) for disambiguation. SVM is supervised machine learning model, and we can make a non-probabilistic classifier with SVM. We apply libSVM library for SVM. Then I describe the procedure with a concrete example. The input sentence is Japanese sentence, which means to fill a glass with water. First, word segmentation and post-tagging is conducted for input sentence, and feature vector is generated from the result. We use 5 features. 3 of them is about the target verb, the target verb itself, and conjugation form of target verb, and type candidates of target verb. In this case, target verb is mitasu, which means either to fill or to satisfy, and conjugation form is original form, and type candidates are action and modification. We also consider the particle occurrence in this sentence. In this example, there are 2 particles, Japanese particles, ni and o. So we use its occurrences as the features. And last, we also use frequency of semantic category of nouns in the sentence. To determine categories, we use Japanese thesaurus for nouns or proper noun. The example sentence includes two nouns, glass and water, and both of them have semantic category concrete object. Then the frequency of the category concrete object is 2 in the sentence. The disambiguator determine one type for the target verb with SVM. In this case, the type action is determined. To evaluate the disambiguator, we prepared 2,000 sentences from Japanese newspaper. We extracted 2,000 sentences from the newspaper. The sentences are restricted to sentences which include one verb having multiple types. In other words, there are 2,000 disambiguation problem instances. Then we manually annotated the most appropriate semantic type for each target verb. The table is breakdown of the annotation for the data set. And we compared the disambiguator with two baselines with using tenfold cross-validation. Two baselines are random and majority. Baselines choose one type from the verb's possible types, and first baseline random chooses one of them from randomly, and second baseline majority chooses the most frequent one in the dataset. The priority is followed. The priority follows the order of modification, change, action, and emotion. For example, for the verb mitas, which means either to fill or to satisfy, always determined as modification, because modification's priority is higher. As a result, our disambiguator achieved 70% accuracy, while baselines random achieved 24 and majority 30. So the disambiguator outperformed both baselines. The table is precision for each semantic type. For the type emotion, achieved less precision than other types. It is because the number of data annotated as modification is the least. So increasing the data for modification or weighting the data during the training can improve the disambiguator's performance. Although achieved accuracy is seemingly low, we believe there are no problem for application because 80% verbs have single types. Then we roughly estimate 90% of all verbs can be labeled with correct semantic type. The disambiguator will be available at our website. Then let me recap my presentation. I introduced the semantic type for Japanese proposed in our previous research and defined the task semantic type disambiguation. It is to determine single type for a verb with the context. Then I described semantic disambiguator we constructed. It achieved 70% for newspaper articles. In future work, I'll apply semantic types to sentiment analysis instead of part of speech features. That's the end of my presentation. Thank you for listening.